So we're going to be talking about when using significant figures in your calculations, when and how to use them, what rules do you use, things like that. So this is when you're not necessarily measuring things, but rather when you're given a number, what do you do with it? Um, so, so first thing you need to do is you need to figure out which digits in your number are actually significant. Most of the time they're significant. There's kind of two cases in which they're not. So if you have non-zero digits, non-zero digits are always significant. So for example, if your number is 23.5, all three of those digits are significant. So we would say that this has three total significant figures. Zeros that are between non-zeros are always significant. These are called trapped zeros because they're trapped by the non-zero numbers. So if you have a number like 1003, these zeros are significant because they're between the 1 and the 3. It doesn't matter whether or not it's just 1 zero or 15 zeros between the non-zeros, but as long as it's a zero between non-zeros, it is going to be significant. Zeros after non-zeros, so these are called trailing zeros, they're sometimes significant. They're only significant if there is a decimal point. So and that decimal point needs to be somewhere in the number. Doesn't matter where it is, as long as there's a decimal point somewhere in the number, those trailing zeros are definitely going to be significant. I have two examples here. So we have 545.70. That zero is significant. Um, it is a trailing zero, so it happens at the end of the number, and it happens in a number that has a decimal point. So it's trailing zero with a decimal point. Now this number has only three total significant figures. This zero right here is a trapped zero, so it's significant according to the second rule. And these zeros at the end, they are trailing zeros, but there's no decimal point in this number. And since there's no decimal point in the number, we know that it is going to be not significant. So the 4, the 0, and the 3 are significant. So we would say that this has three significant figures in it. Then the last ones are zeros before a number. So these are what are called leading zeros. They lead the number. This only happens when you have really, really small numbers. So like 0.00839. These zeros out in front are not significant. So this would only have one, two, three significant figures. Essentially, the zeros that aren't significant, so that would be trailing zeros without a decimal point, and leading zeros, they're essentially just placeholders. They tell you that the number is going to be either really, really big or really, really small. So that's the sort of the basic idea here. Now, if that was a little confusing to you, you can also just remember what is called the Pacific Atlantic trick. So if you look at a map of America, this is a map of America. So uh, if we think about the Pacific Ocean as being over here and the Atlantic Ocean being over here, the way that this works is if the decimal point is present, you start counting on the Pacific side. If the decimal point is absent, you start counting on the Atlantic side. And if it's present, you go this direction, and if it's Atlantic, you go this direction. Um, so the way that that works, if you look at the previous page here, if you look at this one, the decimal point is present. So if the decimal point is present, you start counting on the Pacific side, and you start counting at the first non-zero digits. This would have 1, 2, 3 significant figures. Um, let's look at this number right here. This number has a decimal point, so Pacific side again, and you start counting at the first non-zero digit. So that's 1, 2, 3, 4, 5 significant figures. Our rules here would also tell us that it has 5, but the Pacific Atlantic trick also tells us that we have 5. Let's look at this one. This one, the decimal point is absent. So we start counting on this side, going this direction. And we start counting at the first non-zero digit that we hit. 0, 0, hey look, 1, 2, 3. It's got 3 sig figs. So we know that the Atlantic trick also works. Number like this, decimal point is present. We start counting going this direction. We start counting at the first non-zero digit, so ignore these zeros. 1, 2, 3. So it doesn't matter which way that you remember it. You can remember the rules, or you can remember the Pacific Atlantic trick. It doesn't matter which way you remember it, as long as you know how to look at a number and determine how many significant figures there are. Skip ahead here. All right, I got some examples for you. Go ahead and pause this video and then try to determine the number of significant figures in each one of these, and we'll check our answers here in a second. All right, so if we look at our answers here, these are all the how many significant figures each one of these has. We'll quickly go over these. Here, we do not have a decimal place, so these trailing zeros are not significant, so it's just these 4 that are significant. These zeros out in front are leading zeros, they're not significant, so this only has 2. This has a decimal point, and so these are all trailing zeros, so all of these count, so that's a total of 5. Here we have leading zeros are not significant. These are trapped zeros, so they're significant. This zero is trailing, and there's a decimal point, so all of those are significant, so we have a total of 6. Here, these zeros are trapped. This zero right here is trailing without a decimal point, so it's just those 4 that are significant. Here, all 4 of those are or all 3 of these zeros are leading or trailing zeros without a decimal point, so it's just this 4 that's significant, so it has 1 significant figure total. So let's talk about rounding. Rounding seems to be an issue each year. It's really not a whole lot different than what you're used to in the past, but we just have a couple of little things that we have to worry about with significant figures. So in general, you look next door, and if next door is a 5 or greater, you round up. There are no other rules about rounding. 5 or greater, you round up. Only count the significant figures. So like leading zeros are not significant. You don't count those for the number of total significant figures. You don't do that. Trailing zeros are not counted either. So only count the significant figures. You have to keep your placeholders though. So I said the leading zeros are not significant, but they need to be there still. They need to be there because that keeps the number small. So placeholders still need to be there, whether or not they're big or small, placeholders still need to be there. So we're going to round these each to the number of significant figures indicated. So we want to round this to 4 total significant figures. So all you do is you keep the first 4 significant figures. 1, 2, 3, 4. You look next door. This 2 is not a 5 or greater, so this does not round up the 7. So all you do is you keep these first 4, and you get your answer of 314.7. Let's say we have a really small number, so 0.001775 meters, and we need to round this to 2 significant figures. These zeros out in front are placeholders. They're there for a reason. They don't count for the total number of significant figures, but they still need to be there. Then we keep the next 2. 1, 2. We look next door. Is that a 5 or greater? Yep. So we are definitely going to round up this 7 and make it an 8. So we keep these zeros. This is going to be 1, 8. So our answer is going to be 0.0018 meters. You need to keep these zeros. It's really important that you do that. I always say that there's 2 things that you need to do to kind of check your answer. Number 1, does your answer have the right number of significant figures you're rounding to? Well, if you just look at this number, it's got 2. The second thing is it close to the original answer? 0.001775 is really close to 0.0018. So since these 2 things are close, we know that we have the right answer. And then our last one is kind of a bigger number. We have 8,792 meters. We're going to round that to 2 total significant figures. We keep the first 2. We look next door. That's a 5 or greater, so we round up. So we have 8, 8. Is that the correct answer? No. Because this is 8,792, we're going to essentially convert these 2 digits into placeholders. So we're going to make them with zeros instead. So our final answer is 8,800 meters. So this has 2 significant figures. 8,800 is 2. There's no decimal point here, so these are not significant. But we need to keep it close to the original answer. 8,792 is pretty close to 8,800. So because these 2 things are close, and it has the right number of significant figures, we know that we've done it correctly. All right, so let's talk about how we do calculations with significant figures. Um, so there's kind of two different rules. One is for addition and subtraction. The other one is for multiplication and division. Now, the addition and subtraction rule says this. You're going to round to the least number of digits behind the decimal place. So you look at the number. If one has 2 to the right of the decimal place, the other one has 3 to the right of the decimal place, you're going to round your answer to only 2 to the right of the decimal place. So you're going to round to that hundredths place. Now, for multiplication and division, it's a little bit more complicated, probably the hardest one to do, and this actually happens way more often than addition and subtraction does in chemistry. So multiplication and division, you round to the least number of total significant figures. So you look at all the numbers that you're multiplying and dividing, you figure out which one has the least number of total significant figures, which we just practiced, and then your final answer is rounded to that. So if we look at this one right here, we have 12.52 plus 349.0 plus 8.24. We get an answer of 369.76. Now, if you look at our rules here, this is addition, subtraction. So we look at decimal places. So this has 2 to the right of the decimal. This has 1. This has 2, which means our final answer can only have 1 to the right of the decimal. So we need to round that up. So your final answer is 369.8. So our next one is a subtraction problem. So we have 74.626 minus 28.34. So here we have the answer that we get in our calculator. So you round to least number of decimal places. This has 3, this has 2. Your final answer only has 2. So your final answer is going to be 46.29. So we go into that position, that rounds up. That's how we get the 9 there. Now multiplication and division. So here we have a multiplication problem. 7.55 times 0.34. So you get 2.567 when you put this into your calculator, but this is multiplication and division. So you have to count the number of total significant figures. This has 1, 2, 3 significant figures. This only has 2 because this is a leading 0. So your final answer can only have 2 significant figures. So you keep the first 2 significant figures. 1, 2. You look next door. That's a 5 or greater, so that's going to round up. So your final answer is 2.6. This has 2 significant figures total and is close to our original answer. Division. We have 2.4526 divided by 8.4. And we get this when we put in our calculator. Please do not write this big, huge number down as your answer. We don't ever keep that many digits. So this has 5 significant figures. This only has 2. So your final answer can only have 2 significant figures. This 0 is not significant, leading 0. So we keep 1, 2. That 1 does not round up the 9 because it's not a 5 or greater. So your final answer is going to end up being 0.29. And that's how you do calculations with significant figures.